Hey everybody, hope you're enjoying your day. We're going to start section 10.4 today, which is all about inverse functions. This section starts off with talking about inverse relations. If you remember to our first conversation about functions, we started that with talking about what relations are. A relation is a set of ordered pairs. So any set of ordered pairs is called a relation. In order for a relation to be a function, each x value has to only go to one y value. In other words, each input goes to one output. That's what makes a relation a function. So first, to start the conversation about inverse functions, we're going to start off just talking about inverse relations. So an inverse relation is when a relation contains AB, so xy, the inverse relation contains BA. So you switch the x and the y. So that's what makes a relation into an inverse relation. So it starts off really easy. It just says find the inverse of each relation. So all that you have to do is you have to switch the coordinates of each ordered pair. So negative 4, 7 turns into 7, negative 4. Negative 2, 4 turns into 4, negative 2. 0, 1 turns into 1, 0. 2, negative 2 turns into negative 2, 2. And 4, negative 5 turns into negative 5, 4. You just switch the x and the y, and that's when you get your inverse relation. So the inverse is when you switch the ordered pair around. So the x goes in the y spot, the y goes in the x spot. So if you look at B, it's just a table. It's the same exact situation where they have x and y values, and they're just switching them. So all the x values, all the inputs, go to the outputs, and all the outputs go to the inputs. So they just get switched. So these would be inverse relations because the inputs and the outputs were switched from one to the next. So if you feel comfortable, why don't you just try these two out. So just write the inverse of the relation. Pause the screen, and when you're ready, press play and see the answers pop up. Alright, so to find the inverse of the relation, again, we're just going to switch the x and the y. So it just becomes this. That's the inverse. The inverse of this one would be 0, negative 2. We're not switching the signs. We are literally just switching the x and the y positions. That's it. Nothing else. Sure is a lot of these to drive home the point, but you guys get it, I hope, that everything got switched. The x and the y switched around, so now it's the inverse. So for this one, we're just going to make a table where we switch the x and the y around. So the input becomes the output becomes the input. So we had negative 2, negative 1, 0, 1, and 2 as our input. That is now our output. Our output was 4, 1, 0, 1, and 4. That is now our input. So we just switched it. Now we have made the inverse relation of this here. So this is really the next step. This is the closest step to writing inverse functions. Once you get this down, writing inverse functions is just one more thing. We're going to do that tomorrow, but today, all we're going to do, you've done this before, it just says solve y equals f of x for x. Then find the input when the output is negative 3. So this is what that means. All we're going to do here is we're going to change f of x into y, because f of x and y are equal to each other. And then we're going to solve for x. So we're going to have y equals 2x plus 1. And then we are going to solve for x. So in order to do that, we subtract 1 from both sides. And then we divide everything by 2. So we get x equals y minus 1 divided by 2. Okay, so that is the function solved for x. Now it just says find the input when the output is negative 3. So in this case, the output is still y. So we would say that, we'd make y negative 3. So I'll say x equals negative 3 minus 1 over 2, which is negative 4 divided by 2, which is negative 2. So then we've answered both questions. Alright, so if you got that down, once you try these three out, it's the same exact idea. So you're just solving for x, and then you're finding the input when the output is 4. So pause the screen And when you're ready, press play and you'll see the answers come up. Alright, so for here, we're going to write y equals x minus 6. And then we are going to solve for x. And then we're going to find the input when the output is 4. So the output is still y, so 4 plus 6 equals x. So 10 equals x. Alright, for number 4, we just write y equals 1/2 x plus 3. We would subtract 3. Multiply both sides by 2 to get rid of this half, and get 2y minus 6 equals x. When the output is 4, so that would be 8 plus 6, or minus 6. So x would be 2. For this one, we first make f of x equal to y. Divide both sides by 4. Take the square root of both sides, so you don't end up getting the square root of y over 2 equals x. So if you plug in 4, you get the square root of 4 over 2 equals x, which is 1. Alright, so this is the answer to these three. So that's all we're going to do today. Just these types of problems, keep it nice and simple. If you have any questions, please attend the Google Meet or write it on the Google Doc. If you're doing this during one of the Open Meet times, don't write it on the Google Doc. Attend the Open Meet. Ask me there. That way, you just get your answer instantly, okay? Because I won't be checking the Google Doc while the Open Meets are going on. Alright, so have a good day, good luck, and good luck on the BIM.